Every packet that enters your network has to get past something, and that something is usually a firewall. Welcome to Lesson 43, where we'll explore how firewalls evolved from simple packet filters into the stateful inspection engines and next-generation platforms protecting modern networks today. Think of this as your tour through the first line of defense: how traffic actually gets filtered, allowed, or denied. Here's the path we'll walk together. We'll start with the evolution of firewalls, from basic packet filters through stateful inspection, all the way to today's next-generation platforms. Then we'll look inside the connection table that makes stateful inspection work, before turning to zones, interfaces, and the all-important question of rule order. And we'll finish with real deployment topologies, DMZs, perimeters, and internal segmentation, so you can see how these pieces fit together in practice. Let's begin with that evolution. Firewalls have grown up in three distinct generations. The first, back in 1988, was the simple packet filter. It looked at each packet in isolation, checking source and destination IPs, ports, and protocol, but had no memory of what came before. In 1994, stateful firewalls added a connection table, so the firewall could tell whether a packet belonged to an established conversation. And from around 2009 onward, next-generation firewalls layered on application awareness, user identity, and threat intelligence, seeing not just the flow, but what's actually inside it. The key insight: modern firewalls don't pick one. They do all three at once. That memory lives inside what's called the connection table. And this is what it actually looks like. Each row is one active flow: source and destination, protocol, current state, and a timer counting down before the entry expires. When your laptop at 10.0.5 reaches out to a web server on port 443, the firewall records it here, and the return packets are automatically allowed because they match an existing entry. Anything inbound without a matching row, dropped by default. That's the whole trick. And a serious enterprise firewall can hold millions of these flows simultaneously. Now, once you have a stateful firewall, you need a clean way to organize what it's protecting. And that's where zones come in. Instead of writing rules against individual interfaces, you group interfaces by trust level. The classic design has three: inside, your corporate LAN, fully trusted; outside, the internet, trusted with nothing; and the DMZ in the middle, where public-facing servers like web and mail live. The default policy then writes itself. Inside can reach out freely, outside is denied by default, and the DMZ is reachable from the internet only on the specific ports those services actually need. With zones defined, the next thing that decides whether traffic lives or dies is the order of your rules. Firewalls evaluate top-down and stop at the first match, so a packet from your LAN to the DMZ web server hits rule 1 and never sees the rest. That's why specific allows go first, broader rules follow, and a default deny sits silently at the bottom, catching anything you forgot. Flip that order. Put a deny any too high, and you'll black hole the very traffic you meant to permit. But rule order only matters if your firewall actually understands what it's looking at. And that's where next-generation firewalls change the game. Instead of trusting that port 443 means web traffic, an NGFW uses deep packet inspection to identify the actual application, so Facebook and your banking portal can ride the same port and still land on different policies. Layer in user identity from Active Directory, URL filtering by category, inline IPS signatures, TLS decryption, and sandboxing for unknown files, and the firewall stops being a simple gatekeeper. It becomes a context-aware enforcement point that sees the app, the user, and the content together. But even the smartest firewall is only as effective as where you put it. The simplest approach, a single perimeter firewall between your LAN and the internet, works fine for a home office, but once someone slips past it, they roam freely. Add a DMZ league and your public web and mail servers live in their own isolated zone. So a compromised server can't pivot straight into the internal network. Step up to dual firewalls from different vendors and you get true defense in depth. the layout you'll see in enterprises chasing PCI DSS compliance. And finally, internal segmentation pushes firewalls between finance, HR, and dev, limiting lateral movement when, not if, a breach happens, the foundation of any zero-trust design. Let's see what that three-zone design actually looks like on a Cisco ASA. Each interface gets a name and a security level from 0 to 100. Outside sits at 0, inside at 100, and the DMZ lands in the middle at 50. By default, traffic flows freely from higher trust to lower, but anything coming the other way needs an explicit access list, which is exactly what Step 2 does, permitting HTTPS from the internet to the DMZ web server and nothing else. With the firewall handling zones, the next question is what to do about threats that slip past it, and that's where IDS and IPS come in. The key difference is placement. An IDS sits out of band on a mirror port, watching copies of traffic and raising alerts, while an IPS sits in line, inspecting every packet and dropping anything malicious. That inline position is powerful but risky. A false positive on an IDS is just noise, but on an IPS, it becomes an outage. In practice, modern NGFWs fold IPS right into the firewall, while standalone IDS tools like Zeek still earn their keep for forensics and deep visibility. Now, even a well-designed firewall can fail in operation, and the failures tend to repeat themselves across organizations. The classic one is the temporary allow any rule, added to debug an issue and then quietly left in production. At that point, the firewall is just decoration. Rule order trips people up too. A broad deny placed above a specific allow means the allow never fires. Then you've got stateful asymmetric paths, where traffic enters through one firewall and leaves through another with no matching session, so legitimate packets get dropped. Forgetting to commit or write memory is the silent killer of troubleshooting sessions. And finally, if you're not logging your denies and forwarding them to a SIEM with proper time sync, you'll have no evidence when something does get through. So let's pull the threads together. Firewalls evolved through 3 generations, simple packet filters, then stateful inspection that tracks connections so return traffic flows while unsolicited inbound is dropped, and now next-gen firewalls that understand applications, users, and threats. Zones organize your interfaces by trust level. Rules are evaluated top-down with an implicit deny at the end. And NGFW features like IPS, URL filtering, and TLS decryption extend protection well beyond ports and addresses. Master these 5 ideas, and you've got the mental model you need for real deployments. Here's your cheat sheet for quick reference. Packet filter, stateful, and NGFW mark the 3 generations, while the connection table is what makes stateful inspection possible. 1 entry per flow, tracking source, destination, ports, protocol, and state. Zones group interfaces by trust. The default policy denies inbound and allows outbound, and rules match top-down with an implicit deny at the end. Keep the DMZ isolated. Remember IDS alerts while IPS blocks inline, and lean on deep packet inspection when you need to see inside the application itself. That wraps up our look at firewalls. But the story of traffic filtering doesn't end here. Next up in Lesson 44, we'll dig into access control lists, standard, extended, and named. They're the building blocks that let you shape exactly what moves through your network, hop by hop. If this lesson helped things click, head to dargslan.com or catch the full series on YouTube. I'll see you in the next one.